Hello, this is problem 2-134 from Integrated Math 3. This is the second part of the problem where they're asking you to complete the square again. And this is a circle graph. We've got the x squared and the y squared. Notice I've already rearranged the problem down below to collect the terms that are alike, the x squared and the negative 4x. They're not like terms, but again, we're going to complete the square with the x terms, and then we're going to complete the square a second time with the y terms. And so I need to think about drawing a square. I split the middle term. In this case, it's a negative, so I split that into the negative 2x and a negative 2x. So it's a minus 2 now as the outside dimension. But still, a negative times a negative means you're always introducing a positive. And I add that to both sides. The same thing with the y squared, and we split the middle term, which is 6y and half, so that we have a square. And so again, y plus 3 and y plus 3. Now 3 times 3 means in order to complete the square, because this is representing the y squared plus 6y, we need to introduce something here, and that's 3 times 3, which is 9. That gets added to both sides, and now I could rewrite my equation. I write the dimensions of the square. X minus 2 times x minus 2 is x minus 2 quantity squared. Same thing with the y plus 3 quantity squared. And again, on this side, it's 7 plus 9, which is 16. So the radius here equals 4, and the center is located at 2, negative 3. Now, this is not a circle that I can use a special right triangle like a Pythagorean triple. I realize that the radius is length 4, but the radius would have to be a length 5, the hypotenuse, in order to use that. But we can plot 4 points. So let's do the, again, shift. The shift would be to the right 2, and down, in this case, down negative 3. This is the center of the circle, not on the circle, and we know the radius is 4, so we can just count up 1, 2, 3, 4, and find a point right there. We can go to the right, 1, 2, 3, 4, and there's a point on the circle there. Go down, 1, 2, 3, 4, and finally to the left, 1, 2, 3, 4. And now again, the center is not on the circle, but the center is a reference point, and every other point is equally far away from that. And whenever we don't have these having right triangles, it's not the most perfect circle-y circle, but we can sketch it. There are more points on the graph, but they're irrational and they're pretty difficult to, figure out. We can get a decimal approximation, but that is our circle.